Okay, in this lesson we're going to look at the conic sections for circles. So let's define what a circle is. A circle is a set of all points x and y that are this equal distant from a fixed point. The center is the fixed point, that's equal distance from all the points on the circle, and the distance from the center to any point on the circle is called the radius. So this little picture down here, the center in this particular example is centered at the origin. All the points that are the same distance from that point, a distance of r from the center point, is this circle. Okay. Standard form for an equation of a circle at the origin is x squared plus y squared is r squared. It should look familiar to you. It's very similar and related to, again, the Pythagorean theorem. Because if I draw this as the radius, this could be the hypotenuse of a right triangle sitting right here. And we've talked about this numerous times in different things. So the generic form for a circle with a center at HK, the general form, there it is right there. You can also consider this to be standard or transformational form for right and left and all that kind of stuff. And so we want to be able to draw a circle. So to do so, we want to identify where the center is and the radius of the circle. So if I move things around, I get x squared plus y squared equals 4. And so by this, it tells me my center will be at 0, 0, and my radius is equal to 2. Okay. Why is it equal to 2? Because it is the square root of 4, or 2, because this is an r squared. Okay. And so to draw the circle right here, we need to find our coordinate system, and we need to set this up so we can draw our circle of radius 2. So if we mark this out here, let me get my compass real quick. Move it over here. So depending on how I want to scale this, if I call this 1 and that's 2, then I can come over here and use my compass to draw a circle that's a little bit nicer than a freehand drawing. And so we just get our compass to 0, 0. We mark it out here at 2. And very quickly we can just draw our circle. And there you go. So there's our circle of radius 2. Okay. Here's another example. We have this point that's on a circle centered at the origin. Write the equation of the circle. So usually when you do a problem like this, you always want to write down the formula for a circle, especially one centered at the origin, which we know is going to be x squared plus y squared equals r squared. So we know this, and the only thing we need to find is we've got to find that radius. So to help us find the radius, my recommendation is that you try and draw a quick sketch of this point. So you kind of see where it's at. So here's my center. And if I go over here, 1, 2, and then up to 5, 1, 2, 3, 4, 5, then that right there is a point that is on the circle, which means this is my radius, r, and we want to find that. Okay, so if this point -2, 5 is on the circle, that is x, that is y, I can find r by plugging it into this formula. So -2 squared plus 5 squared is r squared. And then I just solve this for r squared. Okay, so what is that going to be? That's 25, that's 4. So r squared is 29. I don't need to find what r is. I need to know what r squared is because r squared is what's in my formula. I'm done here. If I wanted to find r, then I just take the square root of this, and I'm done. Here's the equation of this circle that goes through that point. And there you go. Okay, let's look at the next thing. These are a couple of theorems from geometry that are important that you want to know. These are the ones that I use most often in circle information because these are used in the real world quite a lot, especially if all your GPSs and stuff use these concepts to help us out. So if I have a line that is tangent to a circle at a point of tangency, then the radius to that point of tangency will be perpendicular to the tangent line. Okay, so I know a radius to a point of tangency is perpendicular to the tangent line. And why would that be important to me? I can use it to find the equation of the line, because the slopes are perpendicular. We know that they are the negative reciprocals of each other. And so I can also use it to help me find where the center is, using slopes and stuff like that to find a line that the center is going to be on. And I can do that a couple of times. The other one is this right here, bisecting a chord. A chord is a line segment that goes through the circle to 2 points on the circle. The diameter is the longest chord of a circle. And what I know is that if I draw a perpendicular bisector of any chord of a circle, then the bisector will go through the center. And this is what they use to, triangulate your position and stuff like that. So you have these 2 points, you do another chord, you do it again, and they're going to cross right at the center of the circle. And so I can use this again to help me answer questions about the tangent line or where the center is and things like that. So you write an equation of the line that is tangent to the circle at that point. So again, I always recommend that you do a visual to kind of see what's going on. So if I draw a quick sketch over here and I have a 1 and 4, so this point right here, this is a point where the line will be tangent to a circle. So this point is on the circle. Okay, and you can check it out. If I plug in a 1 here and square it and a 4 here and square it, I'm going to get 17. Okay, so the center is here. That means this becomes the radius of the circle. Okay, and then I know if I drew a little quick sketch here of a circle, I can draw this out in this fashion and just draw a quick sketch. Here's my circle. Gives you a little better visual of what's going on. Then I know that I have a tangent line at that point, and that tangent line has to be perpendicular to the radius that I have on this circle. And so that allows me then to kind of draw that line right there. I know these are perpendicular. Okay, so think back. To write the equation of a line, I need 2 things. I need a point, and I need a slope to find the equation of that line. Okay, the point is pretty obvious. They gave it to me. It's going to be 1, 4. So I need to know the slope. Well, here's where this rule comes in. If this segment right here is perpendicular to this line, then the slopes are negative reciprocals. So what is the slope of this radius? Well, it's rise over run, which is 4 over 1. So if this slope is 4 over 1, then the slope of my tangent line must be the negative reciprocal of this, or negative 1/4. So my slope is now a negative 1/4. This allows me to use the point slope formula. Y minus y1 is the slope times x minus x1. And then I can distribute this out, move the 4 over here, and get it in slope intercept form, which is this right here, and then 17 over 4. And that's the equation of the tangent line. Remember, 17 over 4 is just, I wasn't drawing a scale here, but you should see this a little bit above 4. Because 16 over 4 would be 4, so it's like 4 1/4. And so even though this is not drawn a scale or accurately or anything like that, you can kind of see we're in the ballpark where we need to be. This one down here is making sure that this is a circle. Now, we talked about this on the very first lesson. I can tell this is a circle because of this reason. Number one, the x squared and the y squared, the coefficients in front of these 2 terms are both positive. They're both the same number. That's what makes this a circle. If these coefficients were different numbers, then it would be a positive. They would be an ellipse. And if one of these was negative, then this would be, the other one would be a hyperbola. To identify the center and the radius, I have to put it into this form. This form shows me the center and the radius. So to put it in this form, I have to do the completing the square process that we talked about the other day. So here it is again. Okay, I'm going to come over here. I'm going to take all the x's and clump them together. I'm going to take all the y's and put them together in a little group. And the constant I'm going to stick off to the side. So that means I'm going to rewrite this as x squared plus 10x. And then I'm going to add something and then immediately take it away. And I'm going to do the y, so be careful of your signs when you do this. Y squared minus 6y. I'm going to add something. I'm going to immediately take it away. And then here's the minus 2. So that's the setup that you want to follow. So then what number goes here? You take this number, including the sign, and you cut it in half. So positive 10 cut in half is positive 5, and then you square it. And then we're going to immediately subtract the same thing. Now, let's do this one for the y's. You take this number, including the sign, so negative 6. You cut that in half. In parentheses, you write negative 3. You square it, and then you immediately subtract it. So I'm adding this number, then I'm subtracting it. I'm adding that number and subtracting it. Now, what we're going to do is these three numbers are going to combine into a new constant. These are going to become a new constant. These number group and this group are going to become the x minus h and the y minus k. Here's how it works. The number that's in the parentheses is what you're going to use. So it's going to be x. Since this is positive 5, you're going to put plus 5 squared. This over here is going to become another one for y. It's going to be y minus 3 squared. Okay, and then we have all these numbers over here that we're doing. So this is minus 25, minus 9, minus 2. So what is that number? We're going to move it to the other side. Okay, so all of these get added up. So 25 and 9 is 34, so that's 36. And we're going to move it over here, becomes positive 36. So we get x plus 5 squared plus y minus 3 squared equals 36. And that is the equation of the circle. The center of the circle is the point negative 5, 3. And the radius of the circle is the square root of 36, which is 6. And so there would be your answer to this problem. Okay? Let's look at another one. So here's a word problem scenario that we can kind of look at and use to help us find answers to some questions. So Diego wants to place a circular pool in his backyard. He has already decided that the pool wall will include the endpoints of a diameter. The diameter is at negative 313 and at 9, negative 3. On the grid of his backyard, what equation describes the location of his swimming pool? So what is the swimming pool's equation? Is what they're asking you to do. And you have the diameter. Remember, a diameter is the longest chord that goes through the center, and it is in the middle of the center. So we need to find the midpoint of that chord. So the midpoint is just simply take the x's, add them together, divide by 2. Take the y's, add those together, divided by 2, and we get the center of the circle, which is at 3, 5. Okay, we need to find the radius of this circle. Okay, so how do I find the radius of this circle? Okay, it's all about the distance that's being traveled. If I know this point here is 3, 5, then how do I get from here to here? What is this distance? Well, we can do the right triangle, Pythagorean theorem. So how far is it from 3 to negative 3? From 3 to negative 3, that is a distance of 6. How far is it from 5 to 13? That is a distance of 8. So then I know that r squared is 6 squared plus 8 squared, which is r squared equals 36 plus 64, which is 100. So I now know that r is equal to 10. Okay? But this is the number I'm going to need right here, the r squared. So there's my center. So my equation is going to be x minus 3 squared, y minus 5 squared equals r squared. And that is the equation of the circle. Okay, so that ends this lesson, and we'll do some problems together in class. And here you go.